Today we're going to take notes on fraction prerequisites. Prerequisites mean before we actually get into our Unit 1 fraction topic, we're going to just think about what we learned before 7th grade math, and we're just going to think about and just review a little bit more on what we already know about fractions. So, let's begin. You can use Notability or you can use a piece of paper to take notes if wanted, but please follow along. So the first few questions, we're going to convert the following mixed numbers into improper fractions. So in order to do that, there's an easy way or a tip that I like to tell my students when doing this. Remember that a mixed number is when you have a whole number right before the fraction, like this right here. And when you have that, it just means the whole number 3 times the 1/4. That's all it means. And now, in order to follow the instructions in converting this into an improper fraction, we're just going to use this method that I like to show my kids. So 3 and 1/4, which is also known as 3 1/4. I like to use what it's called the popcorn method. And when you use the popcorn method, you start from the denominator and then go from the whole number to the numerator and then come back to the denominator. So it kind of looks like a popcorn. And then once you have that going on, we are going to write the state that we're living in right now, which is Texas. And the acronym for Texas is TX. So this is called the Texas popcorn method. And I call it the Texas popcorn method because this is how you can start converting it. So I'm going to use a different number. You go from this way to that way. That's the first step. And that's 4 times 3. So that X is going to be your multiplication symbol. And then you're going to add the 1. So 4 times 3 is 12. 12 plus 1 is going to be 13. So you get your second step and add it, and then you get 13. So you got 12, 13, and then we come back down to 4, but we're not going to do any operation with that. We are just going to leave the denominator as a 4. That's what it means. So we converted this into an improper fraction. Improper means when you have a larger number on the top of your fraction line than the denominator. So this is the improper fraction for 3 1/4. Okay, let's do the next one. Number 2, it says 2 3 6. So I'm going to go ahead and use your Texas popcorn method. Once, it's 12. 2 plus 3 is 15. And then come back down, you get 15 over 6. And that is the improper fraction for that. Okay, very simple. Again, number 3 is 1 2/5. So you can go ahead and use your popcorn method. TX, 5 times 1 is 5. 5 plus 2 is 7. So it's 7 over 5. Number 4. I'm going to just use a problem this time. And then TX for Texas. 8 times 8 is 64. 64 plus 5 is 69. So it's going to be 69 over 8. Okay. And then number 5. Now we have different instructions. It says, convert the following improper fractions to mixed numbers. So now we're going from improper fractions to mixed numbers, so vice versa, the other way around. And this way we can't be using the popcorn method this time, but what we need to do is we need to divide this fraction line by the divisor and the dividend. So whenever you have a fraction like this, you just need to convert it into a mixed number by dividing. So top dog goes in the house, so 55 is in the house, which is our dividend, and then our denominator will always be our divisor. All right, so I'm going to start dividing. 2 goes into 5 2 times. 2 times 4, or 2 times 2 is 4. Subtract it, bring down to 5. 2 goes into 15 7 times. Subtract it, and you get a 1. If we were converting this into a decimal, we would be adding a 0, but now when we have fractions, remember that your remainder will always become your numerator. So your end remainder, what you're ended up with, is going to be on the top, and then your divisor, the 2, stays as your denominator. And that would become your mixed number for that improper fraction. Number 6, same deal. Top dog goes in the house. 4 does not go into 1. 4 goes into 11 2 times. Subtract it, and you get 3. The number that's on the top is your outside number, your whole number. Your remainder will always be your numerator, and your divisor will always be your denominator. So your remainder will be your numerator, and your divisor would become your denominator. Okay. Number 7, we have 15 over 3. So top dog goes into the house, divisor is your denominator. So we know that 3 goes into 15 exactly 5 times. And we know that 5 is our whole number, and we have no remainder at all. So it's just 5. 32 over 10. So again, you're going to divide in order to convert it into a mixed number. 10 goes into 32 3 times. 10 times 3 is 30. And you get a remainder of 2. So again, your whole number is the top number, 3. Your remainder is your numerator. And then your denominator stays the same. 3 and 2/10 would be the mixed number. Or if you see that you can reduce that fraction in the inside, 2 and 2/10, you can say it's 3 and 1/5. So either is fine. All right, going on to number 9, simplify the following fractions. So number 9, simplifying means reducing and just making sure that you are putting all of your fractions in the simplest form. These are not in this fraction, number 9, it says 5/15 is not in the simplest form because you can reduce it. Whenever you have a number that ends with a 5 like that, we know for a fact that it's going to be divisible by 5. So you can divide both numbers on the numerator and the denominator by 5 to reduce this and simplify. 5 divided by 5 is 1. 15 divided by 5, so let's think about how many times 5 can go into 15. That's 3 times. And then we can't reduce this any further because we don't have the same factor in 1 or 3. So it's going to be 1/3. Number 10, we have 80 over 120. So when you see a number that ends with a 0 like that, we know that it has to be divisible by 10. So I'm going to divide it by 10 first. 80 divided by 10 is 8. 120 divided by 10 is 12. Another good way to do that is just crossing out the zeros when dividing it by 10. Let's see if it can be simplified even further. 8 over 12. Well, we know that the factors of 8 are going to be 1, 2, 4, and 8. The factors of 12 are going to be 1, 2, 3, 4, 6, and 12. So we see that 4 works out. So that means we can divide it even further and reduce it. 8 divided by 4 is 2. 12 divided by 4 is 3. So should be 2/3 as our reduced fraction. Number 11. We know that 18 and 21, we need to figure out the factors, and you always can list it like this. So 18 would be 1, 2 because it's an even number, 3, 6, 9, and 18. 21 would be 1, can't be 2. It does work for 3. 7, and 21. Okay, so that means we can find out which one would work, and it looks like 3 would work. So we're going to divide both numbers by 3. 18 divided by 3 is 6. 21 divided by 3 is 7. So 6/7 would be our answer. Number 12, we have 64 and 78. So these are a little bit larger, but we can do this. 2, 4, 8. Let's see, 10 can't work, 11 can't work, 12 can't work. We can take half of it, and it's 32. That means 16 can be 1, and then 64. And then 78, it would be 2 because it's an even number. We can take half of it and say it's 39. That means 3 can work, 13 can work, 26 can work, or does, yes, 26 does work, and then 78. So we can go by 2s if we want, or we can figure out a different one. Let's see. Oh, it looks like that is it. So why don't we just go by 2? And again, if you automatically know that it is divisible by 2, then you can keep on going until you find that it is in its simplest form. So 64 divided by 2. I'm going to do my division real quick at the bottom. And that gives you 32. 32 over 78 divided by 2. That gives you 39. So 39 is on the denominator. So it becomes 32 over 39. And we know that it should not work out even further because it does not have like factors or divisors. So 32 over 39 concludes this fraction at its simplest form. Number 13, I can represent a fraction as a picture. So number 13 says shade in 1/4 of the bar. So we're going to use this whole bar, and an easy way to do this is just to cut it in half. And now we have 1/2. 1/4 means 4 of these, or just 1 out of the 4 of these needs to be shaded. So I can cut another half from that half and try to make it equal. It doesn't have to be perfect, but you can now see that we have 4 equal blocks. And now we just need to shade 1 of them in, 1 out of the 4. And that's it. Number 14, same thing. Now we have 2 out of the 5. So we can't cut it in half because it's 5 different bars. So we can do 1 here, 1 here, 1 here, and 1 here. So we have 5 different bars that look very equal, hopefully. And then we can just shade in the 2 bars out of the 5. And this represents 2 fifths. And that is it for our fraction prerequisites.